Okay. All right, so let's go ahead and get going. So today we're talking about surface area of the triangular prism. Remember, we talked already about the rectangular prism on yesterday, and the triangular prism follows the same rules, except for now, when we look at the skin or the covering, like you saw in the vocab piece, it's a little different. Instead of it being all rectangles, now we're talking about 3 rectangles and 2 triangles. So now we have to consider the area of triangles in the midst of that. So that's what we're going to be focusing on today, is to make sure we do that. Just remember that tomorrow you guys will take a quiz. So if you have not been doing your homework, I highly suggest you do it because it will help you with the quiz. All right, so let's jump right on in. Oh, and let me say this. Ivy had such a great revelation. He was using his notes on his do now, and he said, even though it was the question was a net, because this is what a net is, he used the same method of the long, short, and base by just using that same concept of if I take one side and multiply by the lateral, the longer side, and do the same thing, he was able to get the answer and get it correct. So just know our notes are helpful tools, but on the quiz, you won't be able to use them. That's why I give homework so that you have something great to practice with. All right, let's jump right on into our notes. And don't forget, your do now might include some things about the vocab, so make sure you're paying attention to that. So triangular prism is composed of the following faces. There are 3 rectangles, well, 3 rectangular faces connecting to the base, and 2 triangular. Okay, that's better. Remember, the base of a 3-dimensional object, they do not touch. So when we look at an object of a prism, we know that the 2 base, like the triangles here, they're not touching. So here, we're going to use the dimensions that's listed here, and we're going to apply them onto the shape here. So if I look here at the base, I'm just going to use a color pencil. I have one. If I look at my base here, because I want to make sure I put my numbers exactly where they're supposed to be. If I look at my base, I see that the height of my base is 4. So the height of this base has to also be 4. And that's important for when we're talking about area of a triangle. Why? Because area of a triangle is base times height divided by 2. So I do need the height for my triangles. When I keep looking at my base, I can see here that the very base of my triangle is 6. So the very bases of this triangle also must be 6. And now I got to think about what are the other side measurements. So think about this triangle here, or even our cutout. So today you're going to need your triangular prism, if you have it. If not, just keep watching, because I don't want us to lose focus. So remember that when I form this into a prism, I need to know that if I can identify this base, that's what we did with the green here. This one we've already identified, but it's these side ones that I'm not sure about. Well, let's look at when we form our prism. What touches the sides? Well, the other 2 sides of 2 faces are being touched by the long sides, the slanted sides of the triangle. So what I'm going to do is I'm going to use a highlighter to distinguish that, so I know what measurement goes with what. So here, because when I fold this, we notice that whatever this yellow side is going to make sure it fits with this side, this face, and the blue side of my triangular base is going to touch and fit with the blue side of this face. So when I look at my shape, this is what it looks like. So on here, I got to follow the same concept that my whatever measurement is this side of my triangle is also going to be on this side, and it's going to correspond for there. Whatever measurement, I'll use this color, is for this side is also going to be there because that's where it will touch that shape. And the height of the prism, the 9 is what's here. So now that I know where those go, I can now look here and see what goes with what. Well, the right side of my triangle is a 5. So I know if this is 5, this also is 5. And the left side of my triangle is 5 as well. So I'm going to say 5 there. So this is also 5. So what does that look like in each one of my shapes? That looks like this will be 5 times 9 to find the area of this rectangle. Remember, this one is 6. So this is 6 times 9 to find the area of this rectangle. And this is 5. So 5 times 9 to find that. What about for our triangles? Our base is 6, our height is 4, and we divide by 2. So for our triangles, we're looking at 6 times 4 divided by 2. And don't worry, I'm going to show us the other way of doing this where it's the long, short to help us as well with that, because we'll notice that there's still a pattern that goes on with this, and we're going to identify that. So for A, we know that we said it was 5 times 9, which is 45. B was 6 times 9, which is, what's that? 54. C is 5 times 9, which is 45. So we see that happens twice. D is the triangle, so it's 6 times 4 divided by 2. So that's 24 divided by 2, so that's 12. And the other one is the very same thing, 6 times 4 divided by 2, which is 12. So again, this is one way we can always be sure to get our answers, because we can total it up, which means that we're adding. And when we add them all together, we get 168 square centimeters. Or centimeters square, however you want to view it. I know that's a lot to process, so we're going to do it again on the next one, and we'll take it a little slower and kind of walk through it as need be. So what did we remember from what happened before? I know that one of my sides had to touch here. So I'm going to instantly know whatever my side measurement is here is going to be for one of these, and whatever my side measurement is for the other one has to be for the other one. It doesn't matter as long as one of them follows the other one. This one is going to fall for itself because it's the base of the triangle. So it's going to be whatever they say the base of the triangle is. So those are the most important things. To me, the triangular one is, I don't know, I find it to be a little more easier because it's easy to identify that I can guarantee I know the sides based on whatever my slants are off of my triangle. So when we go in for the numbers, I know for this rectangle, because rectangles are just base times height. So that's 8.5 times 6. The next rectangle, if this is blue, that means it's also 6. This one is 6 because that's what this side measurement is. So these are equilateral rectangles, right? So here it'll be 8 times 5 times 6. 8 times 5 times 6. And then for the triangles, I know I'm going to say the base, which is 6, times the height, 5.2 divided by 2. And then we will find the measurement. So let's look, is there, for this situation, we know that if I can find one, I know them all for this one. So 8.5 times 6, what is 8.5 times 6? Could someone tell us? 51. Okay. So 51. So all of these will be 51 apiece. And then for here, 6 times 5.2 divided by 2. Could someone tell us what they get with that? 15.6. One thing about this triangle that makes it a little sweet is really only two shapes. It's a rectangle and it's a triangle. So rectangle we know is base times height. We plugged in the numbers already. So we said 8.5 times 6, and we got the area of 51. But there are 3 of those, so I know I'm going to multiply it 3 times to get part of my answer. The triangles, there are 2 of those. So it's base times height divided by 2. We said that 6 times 5.2 divided by 2, which is 15.6. So the area is 15.6 times 2. And at the end, it should be 184.2 square inches. Okay. Go to your next page, which is, again, can go into your notebook. All right. So now we're talking about the difference between the lateral and the total. Remember, lateral means no base. And total means I'm adding everything. So if it's lateral, all I need to be concerned about is what's happening in the middle. That's all I would need to focus on. So let's talk about that. All right. So we're going to need a volunteer to help us walk through this one for number 2. We'll start with Caroline. Caroline, if we're talking lateral, what are the numbers that's going to be here? So what 2 numbers will you multiply for that top one? $12 and what? Okay, so she said 12 and 4. Mackenzie, do you agree that it's 4 as our other number? What number do you think it is? You think it's 6. Okay, so for this one, you want to say 12 and 6. Okay, Batul, do you agree? What do you think it is? Why do you say it's 5? So she's pointing out that if this angle is 5, that means it has to go with that side. Remember, every side is going to dictate what happens to one of the sides of the rectangles. So yes, Batul, you got that. It's 12 times 5 will be there. Because this side is 5, all because this one side is 5. And if we don't know for sure, that's why you have your shapes, and that's why I say use some colors. So I know that whatever this measurement is, it's going to always correspond. This measurement is always going to correspond. We will never fail using our tools. So back to you, Caroline. So now we know that's 12 times 5. What are we going to do for the middle one? What will we multiply for that one? 12 times 6. And the 6 is because they already tell us that the base of the triangles are 6. We see that? Okay. And so then the last one, Caroline? 12 times 5, because this one is 5 and that is 5. So that's where she got that from. All right, so let's calculate. What's 12 times 5, Caroline? So 60, and this one has to be 60. And what about 12 times 6? 72. So when I add these three numbers up, what would I get? So because for lateral, it's going to be 60 plus 72 plus 60, and we get what? 192 square feet. Great job. So for total surface area, we need to calculate the area of the triangles. So Mackenzie, can you help us with calculating the area of the triangle here? What numbers will you use to calculate the area of the triangle? One second here. He's not here. What would you use? So 4 times 6, and then she'll divide that by 2, because the height of the triangle is 4, the base of the triangle is 6, and divide that by 2. So what would your area be, Mackenzie? So 12 for this one, and then 12 for that one, right? So she has a 12 and a 12. So when I'm talking total surface area, I'm doing 60 plus 72 plus 60 plus 12 plus 12. And so what would that be, Mackenzie, if you already had 192 and now you need to add your two 12s? So 216 square feet. Great job. I'm going to let you guys do this one for yourself. But before I do that, I want us to identify what will be the measurements of the sides. Sophia, what will be the measurement of this side? So again, we have our shape here. I don't know how that would look similar. How can I figure out what will be the measurement for this side? Where would I take that number from? So look at your triangles. What side of the triangle will let me know this measurement? We're trying to figure out what's the side measurement here, because we already know these are 9s. This was Sophia's question, though. Well, Sophia, do you see why it's 5? Because this side, they connect. You see that? They touch each other. So this is 5. So now that you know that, Sophia, what's the measurement of this other side? I can't hear you. The one that I just made blue. What's the measurement for this side? 3. Good job. So this is 3. So please go ahead and find the lateral and the total surface area. When you have it, do thumbs up. I'll come check yours. And if you're waiting on me, don't wait. Just move on to the next, because the next one we'll talk about the other way that we were doing the math. Yes, very close. This is 4. Oh, I'll take that. So again, we're finding the area of the rectangle. It's still just shapes that we know, rectangle and triangle. Lateral means we're only worried about the middle or the empty space. Well, I don't know. The best way, if you feel like you want to do it a different way, try it and see what happens. But I'd rather you do this the way I showed you, just so I know you at least know how to do it. The way we're showing you, just identifying that these are rectangles and these are triangles. Okay? Okay, so let's look at this last number. If this is 3, we're really saying 9 times 3. You got it. Good job, keep going. Do the total. I'm coming up with it. So just make sure everybody's on the right path. So that's 9 times 3. Then what would this be? 9 times what? Yeah. And what would this one be? And then actually calculate them and add them together like we did here. We just added what we got in those 3. Good job. So then we go. Good job. We're getting that. Good job. I see you. Are you doing that? 5? Is this 4 times 5? Well, is that a 9? So 4 times what? Why would we say times 5 when we're still in 9? So 4 times 9. Yes, ma'am. Okay, so this is 9, right? So should we say 9 times 5? 9 times what's 18? Just making up the number. Oh! Well, that's probably just the base. The height of the base is 1. Because we're doing lateral, so we're going to go over about another one. But yeah. We're about to talk about it. It's going to be the same concept. Yeah. Oh, yeah. Yeah. Well, that's the lateral, not the total. Total will be inclusive base. Okay. Wait, what's the height of this? That's a good question. So someone asked the question of what's the height of our triangles? What's the height of our triangles? The majority of you, I saw correctly, you got the 108 for that. So what do we look for to know the height? We look for the right angle. The right angle of this triangle is here. So what's the height of the triangle? 3. This is the height of the triangle. So when you're calculating for the basis, it's 5 times 3 divided by 2. So 5 times 3 we know is 15. Divided by 2 is what, 7.5? So can we think about something about triangles? Wait, is that 7.5? Yeah. What do we know about whenever we do that? Have we noticed that when I have 2 triangles together, I make 1 rectangle? Have we noticed that yet, or we don't see how that works? Because think about it. If I have to divide by 2 and get 7.5, but I have 2 of them, am I not just going back to 5 times 3? Because 7.5 plus 7.5 is 15. I don't want to confuse anyone, but for those that can handle that, what does that mean? That means I can still view this from the perspective of, instead of I'm using those numbers for my sides. I just don't want to confuse anyone. But if you can see that the connection between the triangles, then it can shorten you by just one small step. But if you don't see it, don't even worry about it. Keep going the way you're doing. So good job. Now let's go back. Let's go here because some of you are waiting for, is there a way I can just do the calculations and not have to decompose it? Yeah, there's always a way to do that. To be able to do it where we don't have to spread it out into a net, because that's what this is. And that's why, like, no matter the shape of the triangle, we can always write it like this and identify what's my sides, what's the height, and connect it to a line. We can do that for any of our shapes. So let's talk about what numbers and like what's important here. So if I'm going to just use the shape, I need to view it as what it is. Each side is a rectangle, right? So if this is a rectangle, do we see that this is just a rectangle what I shaded? I need to know what numbers would I multiply to get this rectangle. 2 and 5. Do you see that? So if I just have the shape, I know for this rectangle here, this yellow rectangle, I'm going to just multiply 2 times 5. 2 times 5. And that's going to be 10, right? Now for this rectangle on the other side, I'm going to shade that a different color if I have one. I guess I'm using a handy dandy pencil. So for this rectangle over here, I'm noticing that the length of it is 4, but how tall is this rectangle over here? I heard someone say 2. Okay, do we all see that? That the height of this rectangle did not change. It's still 4 times 2. So there's my 4 times 2, which is 8. And now I have one more rectangle. I know I be having color pencils, y'all. Okay. No, I don't. I got this. I found one. So here, my orange one, what is my height, or what are my measurements for to find the area of this one? Right. 2 times 3, which is 6. So here I have 8, 10, 8, and 6. So I'm going to write those to the side. So if I just want the lateral, will be 8 plus 6 plus 10, which is, what's that, 18, 19, 20, 21, 22, 23, 24. So 24. And then, so now let's look at our triangle in the middle here. What is the height of this triangle? The height is this 4, right? Because think about it. I always want to find where the right angle is, and wherever the right angle is where I want to use my information. That's where my base and my height for the triangle are going to come from. It's going to come from the height of 4 and the base of 3. But I have 2 of them. So whatever I get here, I'm going to just multiply it by 2, or, you know. So let's see what that looks like. So that's 3 times 4 divided by 2, and I'm also multiplying by 2 because I have 2 base. These 2's can cancel each other out when I do that, so I'm really just looking at 12. So my total will be 24 plus 12, which is 36. Was that too fast for us? They're talking too much. Forgive me. They're not. They're doing fine. Okay, so I wanted us to see, and hopefully, please use some level of utensils and colors. It will help you see that no matter if I have the shape or if I have the net, I can find the surface area because we just did it. I want it to be, but no, I'd rather we